Hello students, this is a review for the unit on systems of equations. We're going to go through a number of different ways to solve systems of equations. We're going to look at graphing, substitution, and elimination, and hopefully by the end of this review, you'll be very confident to deal with the exam that's coming up. All right, for the do now, it says to solve each system. There are three different systems here. You can see that there's no graphs here, so you could assume that we're not going to be graphing any of these, or we're going to be doing graphing a little bit later on in the lesson. But for right now, try to solve these systems with the best way that you know how. Pause the video, try it out, and then come back to see if you got it right. All right, for this first system, my hint is to look for terms that can be eliminated easily. Once you have terms that can be eliminated easily, then you know it's going to be an elimination problem. None of these are inverses, right? This is negative 3x, and this is not positive 3x. This is 3y, this is not negative 3y. However, these can be easily turned into inverse terms by multiplying that second equation by 3. Let's do that now. All right, you can see that I didn't do anything to that first equation. I just wrote it again. But that second equation I multiplied by 3. So I have at least the numbers, the coefficients of x and y that are the same number. So what I can do is choose to either add or subtract these two equations to try to eliminate. Looks like I'm going to go ahead and subtract. The reason I'm going to subtract is because I know that 3y minus 3y is going to give me 0. I know that those are the terms that I'm going to try to eliminate. The rest of the terms here might eliminate as well. We'll check it out. So go ahead and subtract now. Okay, and we got an interesting result. Negative 3x minus negative 3x. If you put negative 3 minus negative 3 in your calculator, you'll get 0. Same thing with 3y minus 3y. That gives you another 0. And then 4 minus 9 is negative 5. My next step in this equation is to simplify, and here's what I get. All right, we'll see that 0 is equal to negative 5 is our quote-unquote solution. There's no x here. There's no y here. There's only two numbers that are not equal to each other. And you remember from the previous unit that when you're solving an equation and at the end of the equation you have two numbers that are different from each other, the answer is no solutions. All right, moving on to the next one. I have 2x plus y is equal to 20 and 6x minus 5y is equal to 12. Again, I'm looking for terms that can be eliminated easily. I have a positive y here and a negative 5y here, so what I'd like to do is multiply the top equation by a 5, right? I'll get negative 5y on the bottom, positive 5y on the top. Then I can eliminate those terms very easily. Let's do that now. Okay, notice I didn't do anything to one of the equations. In this case, it was the second equation because I already had a negative 5y the way I wanted it. This one I want it to be a positive 5y, so I multiplied everything by 5. And now I have 10x plus 5y is equal to 100. Don't forget to do 5 times 20. That's a common student error. All right, now I'm going to try to eliminate these two terms. Looks like I'm going to be adding this time because 5 plus negative 5 is going to give us 0. So here's the addition. And when we add vertically, 10x and 6x is 16x. 5y and negative 5y, these eliminate. I'm not going to write 0 like I did before because I already have something over here. The only reason I wrote the both zeros here is because there was nothing going on the left-hand side. So I wanted to show you that nothing indicates 0. But since there's a 16x here, I don't need to write anything here. 100 plus 12 is 112. Now I'm going to solve this by dividing both sides by 16, and I'll get my answer for x. And I get x equals 7. Now notice in this previous problem, I found that there were no solutions very early on. Like once I did the elimination, I found 0 is equal to negative 5. Instantly tells me there's no solutions, right? Because the x's and the y's both canceled out, both eliminated. Here, I was able to eliminate a y, but I got a value for x. Now that I found a value for x, I know there's going to be a value for y. So I'm going to substitute this value, x is equals 7, into one of the two original equations, and then I'm going to solve for y. I'm going to choose the first equation only because it's got slightly smaller numbers for the coefficients. 2x plus y is equal to 20. So I'm going to write that down here and then substitute in to solve for y. So once again, I took 2x plus y is equal to 20. I wrote it down here. Now I'm going to substitute in the value that I know is for x, which is 7. That goes in here. Now I'm going to try to simplify on the left-hand side by multiplying 7 times 2. And now I need to get the y by itself, isolate the variable. So I'm going to subtract 14 on both sides of the equation to find the value of y. All right, so I found my answer, I found my solution. The solution is x equals 7 and y equals 6. Whenever I'm working on a system of equations with x's and y's, and I have a value of x and a value of y, I can represent my solution in an ordered pair. So I'm going to write that down now. And of course, my solution is x equals 7, y equals 6, so they go in that order. Last but not least, I have a system of equations here, and they're not lined up the same way as these systems of equations were, with an x, a y, a equal sign, and a constant. X, y, equal sign, constant. This top one fits that bill, but the bottom one does not. As a matter of fact, the bottom one is solved already for y. So this is another hint for another type of solution method. I'm looking for terms that can be eliminated easily. That's going to give us elimination method. However, if I have an equation that's already solved for one variable, I'm going to be using the substitution method. So there's your hint. All right, so we're going to take the value of y, which is 4 minus x, and substitute it into the equation up here, which is 2x plus 2y is equal to 8. Then we're going to solve the equation. So here's how it looks. First, I'm going to rewrite the first equation, 2x plus 2y is equal to 8. Now I'm going to take this equation, which is y equals 4 minus x, and I'm going to substitute the value of y in for this y. They're the same y after all. So here's how it looks. Notice the 2 didn't go anywhere, right? Because the 2 was still in the original equation. All I did was take the y out and replace it with parentheses 4 minus x. I put it in parentheses because generally when you substitute and there's a multiplication happening there, we put it inside parentheses. Now we're going to use our distributive property and try to solve this equation for x. And I did my two multiplications. 2 times 4 is 8. 2 times negative x is a negative 2x. Now I'm going to combine like terms on this side to try to simplify the equation before I try to solve. And an interesting thing happens. This 2x and this negative 2x, they actually eliminate, right? The 2x and the negative 2x are inverses, so they eliminate when I add them together. So all I have left on the left-hand side is 8. The only thing left on the right-hand side is 8. So now I have two numbers that are the same exact number that are equal to each other. Back here, when the two numbers were exactly different, we say no solutions. Over here, when the numbers are exactly the same, we say infinite solutions. Similarly, with exercise A, we don't have to take anything and substitute into the second equation because we already have a result that doesn't have any variables in it, so we can tell right away it's infinite solutions. All right, that was a quick review of the do now. Let's take a look at these types of questions. One type of question that you might come up to is this point a solution to the system? Well, in order to figure it out, we got to take the point, the x value and the y value, and substitute those into both equations to make sure that the equations are true. Another way you could do it is to actually solve the two equations. I feel like substituting values into the equations is going to be a slightly faster process, a more efficient process than actually solving the whole system of equations. But it's up to you. It's your call. If you're used to using those three methods to solve, you can do that. Let's take a look at what this looks like. So I've substituted 4 and negative 1 into my equation, keeping in mind that if there is a multiplication, like 2 times y is a multiplication there, I am going to use parentheses. When x is all by itself, not necessary to use parentheses. All right, next step is we're going to simplify on the left-hand side. So we have the 2 equals 2 here. It's a solution to the first equation. Let's see if it's a solution to the second equation. We're going to substitute it in. So we substituted in the same way as we did before, using parentheses if we're doing a multiplication problem. And now let's simplify the left-hand side. And it seems like this one checks out as well. So what we've determined is that 4 negative 1 is a solution to the first equation, and it's a solution to the second equation. So yes, it is a solution to the system. Correct. All right, let's take a look at the second one. 8 negative 5, we're going to do the same thing. We're considering 8 negative 5 to be x and y. And now what we'll do is substitute these values into the equations and then see if the equations become true or not. We'll do the first one first. So here's our substitution step. 8 and 5 went in for x and y respectively. Now let's simplify the left-hand side by multiplying 8 and 5 and negative 4 and 5. And this all seems to check out rather well. I have 40 minus 20, which is equal to 20. So this checks out. So we're good with the first equation. But remember, in every system of equations, we need to make sure that the solution is makes both equations true. So let's substitute it into this equation and see if it works. Now be careful. X and y were in the correct order here, but here y is first, and x is second. So we're going to substitute 5 in for this y and 8 in for this x. Be careful of your placements. Here's how it looks. All right, here's our substituted version. 8 goes in for x, 5 goes in for y, and let's simplify on the left-hand side and the right-hand side at the same time. All right, here's where we run into a spot of difficulty here. 5 times 3 is 15. 8 times 2 is 16 plus 1 is 17. So it looks like these two these two values are not a solution to this equation. So even though the point was a solution to this equation, right, the first equation, it's not a solution to the second equation. So that one does not work. What does that mean for us? Well, when it's a solution for one but not a solution for the other, we say it is not a solution to the entire system. So when you're up against a question like this, is blank blank a solution to the system? You substitute in twice, you get 2 green checks and you're good to go, yes. If you get 1 or more red X's, you say no. Thank you. All right, moving on. Here's an example of the third method of solution. We did substitution and elimination. Let's take a look at graphing. When you're graphing a line, there are 2 major pieces of information that you need. You should remember this from the previous chapter. You need the y-intercept and the slope. Here's what the y-intercept and the slope for the first line. And notice that I wrote this 3, which is the slope, as 3 over 1 because I need a rise over run. And the y-intercept is simply -1. So I'm going to start at -1 here. Here's my y-intercept, the first point that I plot. And then I go up 3 over 1 from this point. So 1, 2, 3 over 1. And then I'm going to do that many, many times until I get to the edge of the paper. And then once I reach the edge of the paper, I'm going to go backwards in the same fashion. Up 3, right 1. I'm going to go downward 3, backwards 1. You can see that it's the same order, right? I'm going to do that again and again and again until I fill up the whole graph. Now what I'm going to do is connect it with a straight line, making sure there are arrows on both sides, and also making sure that there is a label on it. Y equals 3x minus 1 is my label. Now let's take a look at the other equation. Y equals -2x plus 4. Let's write down the slope and the y-intercept for that equation. All right, here's my slope and here's my y-intercept. The y-intercept tells me that the first point I'm going to plot is at +4. So that's here. And I'm going to use my slope, which is down 2 over 1, to find the next point and every point thereafter. And I'm also going to go back to the y-intercept and go backwards. So instead of going down 2 and over 1, I'm going to go up 2 and to the other way 1. Same pattern. And I'm going to fill out the entire chart and then make a straight line that connects all the points. And of course, what linear equation would be complete without a label? So let's put the label on there as well. Now be careful, because some students get so excited at the fact that they've finished their graph, they've graphed both equations, that they just maybe circle it or maybe just like put an arrow towards it, but they don't identify what the solution is. The Regents requires that you identify the solution by its x and y coordinates, especially when you're graphing. So this point, the solution to the system of equations, is +1, +2. The grader will see this and they'll say this person knows exactly what they're doing and they know what the question is asking for. So solution 1, 2. Moving on to the next question, we'll do this a little bit faster. Here's the equation. Let's take a look at the slope and y-intercept. Slope is 3/4, y-intercept is 2, so 2 is the first point. Then I'm going to use 3 over 4 to go up 3 over 4. Up 3 over 4. And make a straight line out of that. Next, I'm going to do y equals 3/2 x minus 1. Here's the slope and the y-intercept. So starting from the y-intercept of -1, start that here. And the slope is 3 over 2, so I'm going to go up 3 over 2, up 3 over 2, and I'm going to continue and make that into a straight line. Once I make those 2 straight lines, it's pretty obvious where the solution is going to be, so we have to write out that solution in an ordered pair form, which looks like this. That solution is 4, 5. Amazing. Moving on, here's another system of equations, 2 other systems of equations, these needing a little bit of solving before we can graph them. Let's graph the one that we can first. This one's fairly straightforward. I start at the point y is equal to -3, which is here. And then my slope is -1 over 2, so down 1 over 2 from the y-intercept, down 1 over 2, etc. Here's my straight line. Okay, not too difficult. However, that first equation, it doesn't have y equals mx plus b form, so the first thing I have to do is solve it for y in order to graph it. So let's take this equation and bring it down here and try to solve it out for y. First thing I see here is that there's a 2x on the wrong side. I want to move that 2x to the other side, so I'm going to subtract 2x from both sides. And now I'm going to divide both sides by 4 to get that y by itself. Here's how that looks. So that 4 divided by 4 eliminates. -2 over 4 is the same as -1/2. 8 divided by 4 is 2. All right, so now let's identify the slope and the y-intercept. So my slope is -1/2, which should set off a little alarm bell in your head maybe. And then the y-intercept is positive 2, so here's positive 2. And negative 1/2 means I go down 1 over 2, down 1 over 2, etc. And then I make a straight line out of that. And the reason before I said that this should set off an alarm bell is when two lines have the same slope. That's a definition you learned about in previous classes. Two lines have the same slope. They are, in fact, parallel. When two lines are parallel, they never intersect, which means you're going to have no solution here. All right, moving on to that last one here. Looks like both of these equations are in the pre-solved stage. They're actually in called standard form. We want to rearrange them to slope-intercept form. So let's do it for the first one first. All right, not too bad. We subtracted 4x on both sides and then divided by 2 to get y equals negative 2x plus 5. So that means our slope is negative 2 and our y-intercept is 5. So that means we're going to start by graphing this equation at the y-intercept of 5. And then negative 2 means we're going down 2 over 1, down 2 over 1, and so on. Connect that with a straight line. And now we have to solve this equation for y. An easy way to do this, I see, is to take this negative y and flip it to the other side, make it a positive y, and then kick the 1 to the other side. So that's what I'm going to do. And even though it's a little backwards of what we are used to seeing it, it still says y equals mx plus b. My slope here is 1, and my y-intercept is 1, or sorry, negative 1. So I'm going to start at negative 1, put a little point there, and that positive 1 slope here means I'm going to go up 1 over 1, up 1 over 1, and then make a straight line out of that. And these two equations are graphed now, which means I can find my solution very easily. That solution is 2, 1. So boom, there's the solution. All right, moving on to the next page here, solving linear systems algebraically. In this case, think back to the hints. How are we going to solve a system of equations in which one of these equations is already solved for a variable? That's right, we're going to use substitution because we know that x is equal to 2y plus 5. Let's substitute that in for x, right? So now let's solve for y on this particular equation. It requires a little distributive property. Keep in mind that we're distributing minus 5 to both of these terms inside the parentheses, and then we're going to be combining like terms. So there's our distributive property, negative 10y and negative 25. Now we're going to combine like terms. And now we're going to move all the numbers to one side, keep all the variables on the other, and try to isolate that variable. So we added 25 to both sides to get positive 24 here. We divided by negative 8 on both sides to get negative 3. So there's our value for y, but of course we now need to find our value for x. My suggestion to you, since this one's already solved for x, just put the value of y into here and then find out what this right-hand side is equal to. Whatever it is, it's going to tell you the value of x. So here we rewrote the equation, that blue equation. We substituted in negative 3 for y. We simplified, and then we combined like terms. X is equal to negative 1. So now our answer, careful to make sure that the answer is in the correct order. I need an x first and then a y, so my solution is negative 1, negative 3. Okay, take a look at that second one here. I am looking for one of the three methods to try to solve this. Doesn't look like our graphing method is going to be viable here. No graph, and also none of these say y equals mx plus b. So let's maybe think of another one. Right, if you wanted to do elimination, that's probably the best way to go about this one. I have a negative 8y here. I can easily turn this into a positive 8y and then add them together to eliminate. So in order to turn this into a positive 8y, I need to multiply the entire equation by 8. So we kept the same equation at the bottom. The top equation, we just multiplied every number by 8, which keeps the equivalence. Now we're just going to add downwards. So negative 24 and 7 gives me negative 17x. 16 and 1 gives me 17. Now I'm just going to divide both sides by negative 17, and I'm going to get x is equal to negative 1. But keep in mind, I am not done. Now what I have to do is substitute this value into the equation to solve for y. Between the two equations I could have chosen, I decided to use that first equation before I multiplied, right? Before I multiplied everything by 8. I decided to use negative 3x plus y is equal to 2, only because that one happened to have a negative 3 for its coefficient of x, and I knew that x was a negative 1, so I wanted those negatives to sort of cancel each other out, which they did. Negative 3 times negative 1 became positive 3. Then I subtracted 3 from both sides, and I got y equals negative 1. Oh, look at that. X is equal to negative 1, y is equal to negative 1. So my solution, -1, -1. Moving on to the next section here. Again, we're going to try to take a look at what is the best way to solve these problems. Keep in mind that sometimes you sort of have to rearrange the problems so that they make a little bit more sense. For this first one, 9y minus 2x is equal to -7, and x minus 3y is equal to 5. Looks like these are a little out of order. Maybe there's a way that you can shuffle these around a little bit. I'm going to use elimination here, but in order to do that, I needed to rearrange these variables so that they were all in the same order. I needed x's first, then y's. So my bottom equation already had x's first, then y's, so I wrote it here. The first equation, I wrote the -2x in the front, and this positive 9y in the second position there. Now that they're in the correct order, x's are lined up, y's are lined up, now I can identify what to multiply both equations by, or one equation by. In this case, it looks like if I multiply this second equation by a 2, I'm going to get -2x and 2x, and that'll be an easy elimination process. So you can see 2 times x is 2x, 2 times -3y is -6y, and 2 times 5 is 10. Now I'm going to add straight down. I'm going to add all of the elements of these equations, and the -2x and 2x are inverses, so they're going to eliminate. And one of the reasons I love elimination so much is because once you eliminate, the equation just gets much, much simpler. The 2x's and the -2x and the 2x eliminate. 9 plus -6 is just 3 for 3y, and then -7 plus 10 just gives you 3. So now I'm going to just divide both sides by 3 and get y is equal to 1. Of course, now I'm going to take that value and substitute it into one of the original equations. Remember, don't substitute it into any of the equations that you rearranged or multiplied by a number. Just pick one of the two original ones. This second one looks like it has smaller numbers and fewer negatives, so I'm going to use that one. So I've substituted y equals 1 into the equation. -3 times 1, of course, is -3. Add 3 to both sides using opposite operations and get x equals 8. So my solution is going to be 8, 1. All right, let's take a look at number 4. In number 4, you're going to choose your method, and one of the methods should jump out to you right away. Try to figure out which one it is, and then come back to see if you got it right. All right, if you chose substitution, looks like that's the easiest one to use here. Y equals -2x plus 3. I'm just going to take this and substitute it in for y. So let's rewrite that first equation, and let's substitute this y with -2x plus 3. So I substituted -2x plus 3 into the equation for y, and then I distributed to get -2 times 2, which is -4x, and then positive 2 times positive 3, which is 6. These two eliminated each other, so 6 was equal to 6. If you recall, that means infinite solutions. Again, once you get one of the equations to be solved as number equals same exact number, you know it's going to be infinite solutions regardless of trying to solve the other equation. You can't solve the other equation because you can't really substitute anything in. It doesn't say, like here it says y is equal to 1. We were able to substitute for y, put it in 1. This is 6 equals 6. That doesn't mean y is 6. That doesn't mean x is equal to 6. It just means that all of the values are always going to work. In other words, infinite solutions. All right, moving on to the next slide here. Another set of equations. Let's just quickly identify what method we're going to use to solve here. And again, this one is substitution because our objective is we're going to try to get this y equals 5 minus x to be substituted into the other equation. As soon as the equation is solved for a variable, we can substitute it in very easily. Here's how that looks. So I have 5x minus 2y is equal to 4, 5x, there shouldn't be a space there, minus 2y is equal to 5 minus x, equals 4. Now I'm going to use the distributive property and try to simplify that left-hand side. All right, that distributive property gave us -10 and positive 2x. We combined 5x and 2x to be 7x, and the -10 came along for the ride. We added 10 to both sides to get 7x is equal to 14, and divided both sides by 7 to get x equals 2. Now we're going to substitute that value of x into one of the two equations. I'm going to pick the second equation because it's already solved for y, and then try to figure out what the value of y is. And since y is 5 minus x, and I know x is 2, 5 minus 2 is equal to 3. So our answer is 2, 3. Or I should say, our solution is 2, 3. All right, the next system of equations here, I'll let you try to figure out which method we're going to use, whether it's substitution, elimination, or graphing. And of course, this one is elimination. We have a 2x and we have a negative x here. These are just waiting to be eliminated as long as this becomes a negative 2x, which means I got to multiply the whole thing by 2. So now we have our original first equation, 2x plus 7y is equal to negative 1. And we have our modified second equation, negative 2x minus 4y equals 4. Now what we're going to do is add them together to eliminate the x term. And again, elimination is very nice because what we're doing is we eliminate one of the variables and then the other variable gets a little bit similar. So it turns out that 3y is equal to 3, and then we divide both sides by 3, y is equal to 1. Now we're going to take that value of y and substitute it into one of the two equations. Let's choose the first one because the second one has a bunch of negatives in it. Let's use the first one instead. So there's our substitution. 7 times 1 is just 7. I subtract 7 on both sides to get negative 8 is equal to 2x, and then divide both sides by 2 to get x equals negative 4. So my solution should be, in the correct order, x equals negative 4, y equals 1. All right, now we move on to another type of problem, the type of problem where they ask you about they give you a scenario, and they ask you which system is going to represent the scenario. It's a little bit different. You don't have to solve, you just have to figure out what it's supposed to look like. But it's actually much easier because the correct answer is there somewhere, you just got to find it. Alright, so let's take a look at number 1 first. Alright, first it says the sum of Teresa and Kathy's weights is 118 pounds. Remember that sum is a mathematical word meaning add. So we're going to be adding two things together, and whatever those two things are, they're going to be equal to 118 pounds. So that makes it a little bit easier to figure out already. Teresa weighs 26 pounds more. More is plus, right? 26 pounds more than Kathy. So we know plus has to be in there somewhere, more than Kathy. Here it says Teresa's weight is T and Kathy's weight is C. Makes sense? Now let's start filling in the information that we have. Teresa's weight is T. So the sum of Teresa and Kathy's weight is 118 pounds. Well, then that means this should be a T. And then Kathy's weight is C. So the sum of Teresa T and Kathy C is equal to 118. So one of the equations should be T plus C equals 118. This one's good. This one's good. This one's an incorrect configuration, right? This one says T equals C plus 118, so that's not it. And this one doesn't have anything that looks like 118 in it, so this one can't be it. It now says Teresa weighs 26 pounds more than Kathy. So Teresa weighs, or is, 26 pounds more than, so 26 at the end here, 26 pounds more than Kathy, right? So Teresa's weight is 26 more than Kathy. So we need to find one that says T equals C plus 26. Let's find that one here. Oh, looks like this one has a typo. So T is equal to C plus 26. That's what this one should say. Let's fix this real quick. I'll make sure to fix that on your document there. All right, so T is equal to 26 plus C. That one's the correct one. This one over here just says T is equal to 26. Teresa doesn't weigh 26 pounds. That's ridiculous, so that can't be it. So the correct answer is choice B. Next, a television weighing 50 pounds and a microwave weighing 30 pounds. And then a TV occupies 4 cubic feet and microwaves occupy 3 cubic feet. Okay, so the TV is 50, the microwave is 30, and each TV is 4 cubic feet, and each microwave is 3 cubic feet. Okay, makes sense. The truck is carrying 1,500 pounds of cargo total. Okay, so one of the equations is going to deal with pounds. And it also occupies 138 cubic feet of space. Okay, another equation is going to deal with space. So we have two equations here, one for pounds and one for space. Okay, so what do we know about the pounds? We know that 1,500 pounds of cargo is going to be the total. So whatever the pounds is going to be, it's going to be equal to 1,500. Well, I know that each TV weighs 50 pounds. So 50 pounds for every TV, right? Each, per, or every means we're going to multiply that number by a variable. The variable here, let's use, let's see, all of the multiple choices use T, so let's use T. Also carrying around microwaves, and microwaves weigh 30 pounds, so 30 pounds per microwave, right? Makes sense. Now let's talk about space. 138 cubic feet of space, so 138 is the total. Each TV occupies 4 cubic feet of space. 4 cubic feet of space, each TV, plus 3 cubic feet of space, each microwave. Look at that. So now we have 2 equations, one for pounds and one for space, and we just have to make sure that we didn't say, oh, 4 cubic feet plus something else equals 1,500 pounds. These are all down here. These are all in cubic feet. 138 cubic feet, 4 cubic feet, and 3 cubic feet. These are all in pounds. 1,500 pounds, 50 pounds, 30 pounds. Now let's see which one of the multiple choices works for this one. I got 50t plus 30m is equal to 138. That's no good because 50 and 30 are pounds, and 138 is cubic feet, so that's not it. 50 plus 4t is equal to 1,500. That doesn't make any sense because 50 is not even multiplying by anything. 50t plus 4m is equal to 1,500. That's not going to work either because remember 50 is pounds and 4 is going to be the cubic feet. 50t, 30m, 1,500. There we go. And then 4t, 3m, 138. There we go. Their equations are flipped around from ours, but it doesn't matter. Equations are equal regardless of direction. All right, cool. Moving on to the next page. Often when doing problems like this, you want to try to identify the variables first. Now, before looking at the multiple choices, the Country Buffet restaurant has tables that seat 6 people and booths that seat 4 people. Okay, so right away we're talking about tables and we're talking about booths. So I'm no expert on this. Just kidding, I am. I'm your math teacher. But tables, let's abbreviate as T, and booths, let's abbreviate as B. Now, I know that eventually we're going to talk about the number of people, so it's going to be 4B and 6T, but let's hold off on that. The restaurant has 38 seating units, 38 places for people to sit. So, well, there are tables and there are booths, and there's 38 of those things. So I know that tables plus booths is equal to 38, right? Places for people to sit. For seating a total of 188 people, well, 188 people is accommodated by 6 people per table plus 4 people per booth. That's equal to 188. Okay, so we have our 2 equations. Let's go through and see what the correct answer is. T plus B equals 38. This one looks good so far. These ones look like nonsense. T plus B equals 38. That looks good. T plus B equals 188. That's no good, right? 6t plus 4b is equal to 188. I think that one's right. 4t plus 6b. Now, you see what they did here. 4t, that means 4 people to a table. Table seats 6 people, so that's no good, right? So this one's the correct answer. 6 people at every table, 4 people at every booth. The perimeter of a rectangular wooden deck is 90 square feet, so you know that perimeter of a rectangle is equal to all of the widths, or 2 of the widths, plus 2 of the lengths. And in this case, it tells us that the perimeter of the deck is 90 square feet. So we can say that this equation is 90 equals 2w plus 2l. Just from that information, I can go through and say, well, L plus W is equal to 90. That's no good. That's not how you find perimeter. L plus W is equal to 90. That's not how you find perimeter either. This says that the deck's length is 5 feet less than 4 times its width. Let's try to piece this together one by one, piece by piece. The deck's length is 5 feet less than, so something, something, something minus 5. 5 feet less than 4 times its width. Okay? 4w minus 5. 5 feet less, that's minus 5. 4 times its width, 4w. So there's our second equation. Let's look for the one that says L equals 4w minus 5. Look at that. Seems like we found our answer. Perfect. Moving on up. LeBron James, I don't know if you've ever heard of him. He's a famous golfer. Made 16 baskets. Some were 2-pointers, some were 3-pointers. He scored a total of 39 points. How many 2-pointers and 3-pointers did he make? Well, 16 baskets total. Some were 2-pointers, some were 3-pointers. So we don't know which ones are the 2-pointers and which ones are the 3-pointers, but we know that there are some 2-pointers and some 3-pointers. Let's call the 2-pointers x. Why are we using x? Well, I mean, I'm not going to use 2 or 3. Let's use x for 2-pointers. And then for 3-pointers, let's use y. So x is equal to the number of 2-pointers, right? And y is equal to the number of 3-pointers. He made 16 baskets, which means however many x is and however many y is, I'm going to add those together, and that gives me 16. X plus y equals 16. He scored a total of 39 points, which means 39 is going to be equal to what happened when he did a 2-pointer. Well, each 2-pointer gives him, you guessed it, 2 points. And each 3-pointer, or y, gave him, you guessed it, 3 points. So 2x plus 3y is equal to 39. So now it asks us how many 2-pointers and 3-pointers did he make. Now we're no longer trying to do a multiple choice question. Now we're trying to solve this system of equations. So we're going to try again to figure out which method is best. Should we use substitution, elimination, or graphing? Pause the video and try to figure that out. In this particular case, I would prefer to use elimination. I have a 2x here and an x here. I'm going to change this x to a 2 and just do a subtraction problem. Okay, so I need this to be a 2x, which means I'm going to multiply everything here by the number 2. Multiply this by 2. And that's going to come out over here. So all my coefficients have changed to 2 and 2. My 16 turns into a 32, and my second equation stays the same. Now what I'm going to do is subtract the 2 equations from each other. I'm subtracting because they're both the same sign, which means I need to eliminate them somehow. 2x minus 2x is going to give us that eliminated x, the one that I want. Right? So here's how it looks. Beautiful. That's what I like about elimination. The 2x's go away. I'm left with negative y equals negative 7, which means that y is equal to 7. So that tells me that LeBron James made 16 baskets. 7 of them were 3-pointers. So I can write that down right away. Now you might be able to use mental math to figure out how many 2-pointers he scored, but let's use the system of equations. I'm going to use x plus y equals 16 and substitute in that 7 to try to figure out what the value of x is. And we find out that he scored 7 3-pointers, which means he scored 9 2-pointers. 7 and 9 is 16. And if you take a minute to figure out how many points he would get from 9 2-pointers, that's 18. How many points he would get from 7 3-pointers, that's 21. 18 and 21 is, in fact, 39. All right, coming up to the end here. Jack makes $8 working at McDonald's per hour, right? $8 per hour, that means we're multiplying by the number of hours. And $9 per hour working at Hollister, there's that per hour again, we're multiplying that $9 per hour. This past week he worked 3 times as many hours at Hollister as he did at McDonald's. He made a total of 385 this past week. Not that bad. How many hours did he work at each place? So the question sort of informs us as to what we're looking for. How many hours did he work at each place? So the 2 unknowns that I have are the number of hours that he worked at McDonald's and the number of hours he worked at Hollister. It seems to me that I would use M to symbolize how many hours he worked at McDonald's, and H for the hours he worked at Hollister. Now be careful, I'm using H for Hollister, not for hours. M is hours working at McDonald's. So let's set up our 2 equations. The first equation should represent how much money he earned in total. All right, he made $385 this past week, so whatever the equation is, it's going to be equal to $385. How come it's not typing? Aha, here's the reason. Equals $385. And then I need $8 per hour working at McDonald's, so $8 per hour working at McDonald's, I should say, and $9 per hour working at Hollister. So this is one source of his money. This is another source of his money. The total of that should be $385. Now let's do an equation that deals with the total number of hours. It says he worked 3 times as many hours at Hollister as he did at McDonald's. Here's how that looks. So since this is kind of a confusing wording, I'm going to try to give you a little trick to try to figure out what it should be. It's obviously not M equals H because it says 3 times as many hours at Hollister as he did at McDonald's. So think real quick. If he worked 1 hour at McDonald's, How much did he work at Hollister? Well, 1 hour at McDonald's. He worked 3 times as many hours at Hollister, so 1 at McDonald's means 3 at Hollister, right? If he worked 10 hours at McDonald's, he worked 3 times as many hours at Hollister, so 10 at McDonald's means 30 at Hollister. Which means, if I were to set these two things equal to each other, that means whatever the McDonald's hours are, I would have to multiply them by 3 in order to equal the Hollister's, right? If there's 1 at McDonald's, there's 3 at Hollister's. So for every 1 at McDonald's, there has to be 3 of them to be equal to the Hollister's. Hopefully that makes sense, right? And let's test it out with our 2 examples, right? We said if there's 1 hour at McDonald's, there's 3 hours at Hollister. 1 times 3 is 3 equals 3. That works out. If there's 10 hours at McDonald's, there should be 30 hours at Hollister. Well, 10 times 3 is 30 equals 30. So hopefully that makes sense. Now I have my 2 equations. It should be fairly straightforward which method we use, but pause the video, try it to figure out a method, and then see if you got it right. That's right, this one should be substitution. I know that we've already solved one equation for h, so we'll just take that and substitute it into this equation where h should be. So there's our substitution. I took out h and replaced it with 3m. Now I'm going to solve for m in this equation. And in this case, I didn't even have to use distributive property. 9 times 3 is 27. Combine like terms to give us 35m, and divide it by 35 to get m is equal to 11. Now, if I know that m is equal to 11, I can substitute it into this equation to get the number of hours at Hollister. Here I go. All right, and let's just make sure that this makes sense. He worked 3 times as many hours at Hollister, 33, as he did at McDonald's, 11. That makes sense because this is 3 times as many hours as this. So let's finish it off with a sentence, just like we did with the LeBron problem. So we know that Jack worked 11 hours at McDonald's and 33 hours at Hollister. All right, moving on to the end here. Maria sold raffle tickets for $3 and box of cookies for $5. You should already see where this is going. We have 2 unknowns already. We don't know how many raffle tickets she sold, and we don't know how many boxes of cookies she sold. But she did sell 7 more boxes of cookies than raffle tickets. So whatever the number of raffle tickets was, the cookies is 7 larger than that. And she made $75. How many did she sell of each? So let's set our variables first. All right, we have R as raffle tickets and C as cookie boxes. So I have $3 raffle tickets and $5 boxes of cookies and a total of 75. So the first equation that we're going to write is the equation about money. So 3R plus 5C, 3R because $3 per raffle ticket, 5C, each cookie box is $5. That's equal to $75 in total. Next, we're going to talk about how many items there were. So I guess we'll call that items is the next equation. And again, let's think this through. She sold 7 more boxes of cookies than raffle tickets. So which one of these numbers is going to be bigger, the box of cookies or the raffle tickets? Well, the box of cookies is going to be a bigger number. The raffle tickets is going to be a smaller number, which means if I were to start out with an equation, I know that, like I said, the boxes of cookies, the C, is already going to be bigger than the raffle ticket number, which is R. So in order to make these two equal, I got to make this side bigger. Again, the raffle tickets I didn't sell as much of than the cookies. I sold 7 more boxes of cookies than raffle tickets. So it's a weird construction with the sentence, but it just tells me that R plus 7 is equal to C. Now you might want to do C plus 7 because it says 7 more boxes of cookies. However, if I did that, I know that there's more cookies than raffle tickets. So if I take the already bigger number and add something to it, that's not going to make an equation, right? The equation means both sides have to be equal. So I have to sort of start the equation first and then fill it in with what makes sense. All right, now we have a bunch of information. Let's try to figure out what method we're going to use. So you probably guessed it by now. We're going to use substitution here because this has C equals R plus 7. We're going to take this second equation, the first equation, substitute C for R plus 7, which is exactly what I did here. Now, true to my word, I am going to solve this equation by using distributive property and combining like terms. What I want you to see by the end of this video here, as we're rolling down to some of the last questions, is that really all of the questions that we've done so far are pretty similar. You write out a system of equations, or you're given a system of equations. You pick a method, substitution, elimination, or graphing. You apply that method to find one of the variables, and then you just substitute that variable into the equation to find the other variable. It's really very similar once you see it over and over again. And there's our answer for R. We distributed combined like terms, subtracted 35 from both sides, divided by 8, and we got R is equal to, oh, not 8. 8 times 5 is 40. Whew, good catch, Mr. Squirty. So now that means there are 5 raffle tickets that she sold. Not that many, actually. So if she sold 5 raffle tickets, how many boxes of cookies did she sell? Well, we know that R plus 7 is equal to C, so we can apply this equation to try to figure that out. Here, a very simple substitution. 5 goes in for R, and then I solve and get 12 equals C. Now let's see. She sold 7 more boxes of cookies than raffle tickets. 12 boxes of cookies, 5 raffle tickets, a difference of 7 between them, more boxes of cookies, right? That's another good keyword. There are more boxes of cookies, which means the other side of the equation should be the one that gets pumped up. All right, we write a sentence just like this. Excellent. 5 raffle tickets, 12 boxes of cookies. Moving on. The local business was looking to hire a landscaper. They narrowed the choices to 2 companies. So Flourish charges a flat rate. That flat rate just indicates that it is not including anything else. It's just $120 per hour, right? So 1 hour is 120, 2 hours is 240, 3 hours is 360, and so on. Green Thumb charges $70 per hour plus a $1,600 equipment fee. So cheaper per hour, but more upfront, right? This is an upfront cost that doesn't have to be paid over and over again for every hour. It's just, they pay it once and that's it. So first, let's write a system of equations representing how much each company charges. What we want to do is figure out what our x and y axes are first, and then we will be able to write these equations. So first, let's figure out what we want on x and what we want on y. In all problems dealing with money and time and things like that, we generally want the time to be on the x-axis and the money to be on the y-axis. As a matter of fact, most of the time we're going to want money on the y-axis for the reason that as time goes on, time is, we call it the independent variable. It's gonna keep on going regardless of what we do. But as time goes on, money is going to increase or decrease depending on what time is going forward. So we call money the dependent variable. Again, independent variables the x-axis, dependent variables the y-axis. Anyway, time is on the x, money is on the y. So that means our time, whatever it is, in this case it's going to be hours, is going to be represented by x, and the money is going to be represented by y. So let's take a look at the Flourish Landscaping Company. It's a flat rate of $120 per hour. So I set up the equation y equals 120x. Y, the amount of money spent, is equal to 120 times the number of hours, x. Okay? So that's a fairly straightforward equation. It doesn't change any other way. It's just 120x. The next equation that we have to make is for Green Thumb, which is 70 per hour. There's our slope, the 70. That's going to be multiplied by x, plus a $1,600 equipment fee. It seems to be that is a constant, so that's going to be our y-intercept. So again, that per hour is going to be the slope, per hour is going to be the slope, and then that 1,600 is going to be the y-intercept. There's no y-intercept here because it's just 120 per hour. So now what we can do is graph those equations on the xy axes and scale and label the axes. I feel like time, like each of these individual lines should indicate like an hour, like 1 hour, or maybe 2 hours, right? Because these landscapers, they're probably not going to be working for, hundreds and hundreds of hours. We probably only need it to go up to, let's say, 30 or 40. So let's see what the scale looks like. So here you can see I skipped by 2s, 2, 4, 6, 8, 10. 12, 14, 16, 18, 20, etc. And then for money, we're not sure exactly how far up it's going to go in terms of money. So let's see, this graph goes up to 30, 32, 34, 36. Let's just figure out how much money it would be for Flourish and how much would it be for Green Thumb if we put in 36 hours. And then we'll be able to figure out what the maximum scaling should be. All right, if it was 36 hours, this would become 120 times 36, which is 4,320. And then for Green Thumb, looks like 70 times 36 plus 1,600 is 4,120. So we need to go up past, 4,320. So let's count the number of lines here. So we know that there's 18 lines here going up. I wouldn't be able to skip by hundreds because then I would only be get up to 1800. I can't skip by 200s because then I would only get up to 3600. I could skip by 300s. 300 times 18 is going to be, that would be 5400. I think that's maybe a little high. So what if we skipped by 250s? Well, if I skipped by 250s, 250 times 18 is 4500. So that would be perfect for 4320 and 4120. So let's do that. We'll skip by 250 each line, which means every 4 lines we're going to be up to 1000. All right, it's all starting to come together. Now let's start with trying to graph this flourish one. I know flourish has a y-intercept of 0, so that's an easy enough point to plot. And the next point, if it was 1 hour, 120 times 1 is 120. I mean, I'm not really scaling by something like 120, right? This is 250, this is 500, this is 750, and this is 1000. So maybe I won't try to skip only by 1 hour. Let's see, what happens if I put in 10 hours? What would that, oh, actually, wait a second. We already have, our 36th value. At 36, it's 4,320. So this is 4,000, this is 4250. So 4320 is going to be right around here. So I'm going to put my dot here. And then I'm going to connect this point and this point with a straight line. Yes, that's right. You only need 2 points to make a straight line. Not bad. Now let's do green thumb. Green thumb starts at $1,600. This is $1,250. This is $1,500. $1,600 is going to be right above there. So we'll put a point there. And we already have a point for the 36th hour for x value equals 36. And that's 4120. So here's 4,000. Here's 4250. 4120 is going to be in between there. So let's put a point there as well. That's going to go around here. And now let's connect those two with a straight line. Okay, all in all, looks pretty good. So we've done letter B. At what point in time will the companies, it should say, charge the same amount of money? Explain your answer. Well, we did a little estimating here. This point is around 1600. This point is around 4320, etc. But it really looks like they cross very close to this line. And this line does indicate 32 hours. Let's just see what the values are for each equation at 32 hours. And will you look at that? 3,840 for 120 times 32, and 70 times 32 plus 1,600 is 3,840. So the answer is, at what point in time will the company charge the same amount of money? The answer to that should be after 32 hours. And since it's asking for an explanation to explain your answer, well, it's because the lines intersect there. That's how we know that they're going to be spending the same amount of money. Pretty good. Okay, this was the video about the review for systems of equations. You're not going to necessarily answer all of these questions or really all of these types of questions on your test. It's going to be a shorter test. Obviously, it's only 45 minutes long, but you needed to know all of this stuff in order to prepare you for the test that's coming up. All right, folks, good luck studying.